Hi future doctors, welcome to the next class. In this class onwards, in optics, we will discuss wave optics. So in this lesson, light rays will be traveling in the form of waves. Again, from where light ray or light wave is going to be coming means from source. We are taking point source. So if we are taking point source, generally light ray will be drawn like this. This is the light ray. Then how the wave we are going to take? Every point source is going to give wave in the form of spherical wave front we are going to see. How that spherical wave front will draw means locus of all the points which are in same phase. Locus of all the points which are in same phase. These particles which are in same phase. So you cannot draw these like this. So now this is nothing but spherical wavefront. Point source will produce spherical wavefront. How this intensity is going to be written, drawn. So if you close like this, it will be coming like spherical. Intensity is nothing but already we have given P by A, power by area. So P by 4 pi r square at this point. So intensity is inversely proportional to r square. Next, this wave representation we will represent like this. Y is equal to A sine omega t plus phi. Phi is nothing but phase. If two waves are coming, they will write generally y1 is equal to a1 sine omega t, y2 is equal to a2 sine omega t plus phi. So phi is the phase difference. A1, A2 are amplitudes, y1, y2 are displacements. How intensity and amplitude relation generally they are going to give? So intensity, this is distance. Intensity is directly proportional to square of the amplitude. This is for point source I am saying. So wavefront means locus of all the points which are in same phase. So for wavefront, how the light ray will be taking, because we have to validate light ray also. So light ray is making how much angle with this wavefront means 90 degrees. So one time they asked this, what is the angle between wavefront and ray of light. Always these two are perpendicular. So this is relation between intensity and this distance. Now what is the relation between amplitude and distance for point source? A square is inversely proportional to r square. Therefore, amplitude is inversely proportional to r. This is for point source. So now what is plane wavefront? Generally, we will be having plane wavefront also. How we will take plane wavefront means, if we are having large spherical wavefront, small portion if you cut from this. So this one only we are calling it as plane wavefront. For this plane wavefront, light ray is always making 90 degrees. For always wavefront, incident light ray or angle between wavefront and light ray is always perpendicular or 90 degrees we are going to say. Next, this source if you are taking like this, linear source we will say. From this also you are going to get light rays like this. Now what is the nature of the wavefront? So for linear source or line source, wavefront is going to be spherical. Now how intensity is going to be varied? Intensity is going to be same formula. In EM waves also we discussed. Now what is the area of this means? This is R, this is going to be L means. P is equal to 2 pi RL. Now how intensity and R will be related means intensity is inversely proportional to R. How amplitude will be related means amplitude, intensity is directly proportional to square of the amplitude. So A square is inversely proportional to R, A is inversely proportional to root R. These are important in competitive exam. Next, if you are taking plane source. So for plane source, intensity does not depend on distance, R power 0. They are going to ask this one also. Same like that, it is directly proportional to, intensity is directly proportional to A square. So amplitude also does not depend on distance. So A square also is directly proportional to R power 0. So this is about wavefront and what is the angle between incident light ray and wavefront, and what is the relation between intensity and distance, amplitude and distance, and intensity and amplitude. So if these two waves got superposed each other, then what is the resultant wave? Resultant wave they will write generally superposition principle. Y is equal to y1 plus y2. So they will write a1 sin omega t plus a2 sin omega t plus phi. So you will expand this. Whenever you are expanding a1 sin omega t plus a2 sin A cos B plus cos A sin B. Correct? Now A1 sin omega t plus you can expand. A2 sin omega t cos phi plus A2 cos omega t sin phi. So you can take sin omega t terms. So sin omega t if you are taking common A1 plus A2 cos phi. Sin omega t you are taking common plus this term you are writing general A2 cos omega t sin phi. So this term whichever you will be having A1 plus A2 cos phi, you can write it as another one that is going to be R cos theta, you can assume. So this is amplitude term. R cos theta is A1 plus A2 cos phi. Next, here you are taking cos term. Sin omega t is remains same. Now, here cos omega t can remain same. Now, A2 sin phi you can take. A2 sin phi. That one you can write R sin theta to get representation for another wave. Whenever these two waves got superimposing each other, resultant wave means amplitude and displacement we are calculating by using superposition principle. In place of A1 plus A2 cos phi, what we can write? So cos phi is there means cos theta. Therefore, from this equation, y is equal to A1 plus A2 cos phi, what we can write? R cos theta. So R cos theta sin omega t plus in place of A2 sin phi, what we can write? R sin theta. R sin theta, what will be remaining? Cos omega t. So if you are taking, so R is common, sin A cos B plus cos A sin B. What is the formula? Sin A cos B plus cos A sin B. So sin omega t plus theta. Some people will say directly also, no problem. But this is the main equation. This is the resultant wave displacement equation. Now, what is capital R means? After superimposing these two waves, what is the resultant wave amplitude? Let us assume both are going to be incidenting like this. Crest and crest. This is crest and crest. A1, A2. This is A1, this is A2. Then resultant wave, let us assume it is coming like this. And this is A1 plus A2. To represent that, capital R is going to be representing A1 plus A2. Sometimes those two waves will be superpose each other like this. Opposite. This is A1, this is A2. So resultant wave will be little bit less amplitude, that is A1 minus A2. This A1 minus A2, A1 plus A2 represented by this capital R. So you can call these two equations number 1 and number 2. So from that, how you will get, so that resultant amplitude we will see. Now see from equation 1, R square cos square theta equal to A1 plus A2 cos phi whole square. Like that, R square sin square theta A2 sin phi whole square. Correct? Now if we add these two, R square cos square theta plus sin square. So if we expand this, A1 square plus A2 square cos square phi plus 2A1 A2 cos phi plus A2 square sin square phi. So this is equal to 1. R square equal to. So what will be coming right side? A1 square, if you have taken common A2 square, cos square phi plus sin square phi. plus 2a1 a2 cos phi. So now this is equal to 1. Now r square equal to a1 square plus a2 square plus 2a1 a2 cos phi. Now resultant amplitude a1 square plus a2 square plus 2a1 a2 cos phi under root. This is the equation you should remember for resultant amplitude. Some people will write A also. Resultant amplitude of the two waves which is getting superposition or superimposed each other. Now what is the resultant intensity? So we said intensity is directly proportional to A square or R square. Intensity is directly proportional to R is means here amplitude. A is means here amplitude. I1 is directly proportional to A1 square. I2 is directly proportional to A2 square. Therefore, so this is, if you are writing as R square means I is directly proportional to, or I is equal to, you can write no directly proportional because is equal to is there. I is equal to I1 square, I1, A2 square, I2 plus 2. A1 means from this what is A1? Root I1. What is A2? Root I2. Therefore, 2 root I1 root I2 cos phi. So this is the resultant intensity equation. So in this entire thing, we have to remember that intensity, distance, amplitude relation, and later finally this resultant amplitude equation you should remember, and this equation you should remember. That's all. So if you remember these equations, how we are going to apply for the given problems, we will see in our next class. So I hope you people understood. So this derivation is not required, just you have to remember these final equations. These are easy for you. First year also we will be having resultant formula a square plus b square plus 2ab cos theta. Same formula you are going to get. Here phi is phase difference between these two waves. From that how we will get maximum minimum, we will see in our next class. Thank you.